the modern world, CO2 emissions pose a significant threat to the environment. The primary sources of CO2 gas includes transportation, power generation, construction, and industrial combustion. These sectors collectively contribute to the rising levels of CO2 gas, exhibiting the environment and detrimental effects on the ecosystem as well as on the human health. Therefore, mitigating its harmful effects is crucial to have a sustainable environment.
Well, as mentioned that transportation and power generation are major sources where CO2 is actually being produced. Well, after we look into transportation, we see that hydrocarbons, mainly petrol and diesel, are getting burned in order to produce energy and getting CO2 as a waste product. So after seeing this, we thought that can we actually get hydrocarbons back from CO2? Well, after doing a bit of research and we find out, yes, we can actually do that. So for that purpose, we have designed a reactor. It's an electrochemical reactor in which what happens is that gaseous CO2 is utilized to produce hydrocarbons. Here, basically, we have focused upon formic acid. Okay. So first of all, the major challenges were that CO2 in itself is quite stable. So you cannot just take it and reduce it into whatever you want. So you have to use catalysts. Okay. And catalysts are basically some things that facilitate or basically is used to complete a reaction. So here, for this purpose, we have designed a catalyst on our own, which is basically your activated charcoal on Teflon. Now, activated charcoal is providing your surface area. Basically, the more the surface area, the more the reaction will happen, more the product would be formed. Teflon is providing as a support. Okay, activated charcoal, as you may see, is a powder. So you cannot just use it directly. It has no strength on its own. Therefore, Teflon, which is PTFE, is used. It is a polymer. So it's a polymer-based catalyst we have developed. The major features of the catalyst is that it is hydrophobic, which means that water cannot get into it. And why this is important is that when CO2 is getting reacted or getting reduced, if CO2 is directly put into water, it will form carbonic acid, which is not actually useful to us. Therefore, the separation of CO2 and water is necessary. Therefore, we have developed a catalyst which is hydrophobic. Okay, so from here, as you can see from one hole, the CO2 will be getting inside, okay? And after the electrochemical reduction happens, you will get the necessary products, okay? The reaction will happen in water only when you put the device, the reactor into water and just turn on the power supply. It uses minimal voltage of 5 volts and ampere of 0.1 ampere something. So after 30 or 35 minutes, you will get a decent formation of formic acid and that you can actually check. Now what is actually happening is that on the cathode side, okay, CO2 is getting reduced, but also, as you may have heard me, that water cannot get inside, okay, because it is hydrophobic. But when you pass on the current on the cathode, which is negative, water in itself is not a neutral molecule. It has poles, partial positive and partial negative. Partial positive as the hydrogen side and partial negative on the oxygen side. Okay. So partial positive hydrogen are attracted to the cathode, which is negative, and then carbon dioxide is also getting supplied there. So COOH minus, which is formate ion, is getting produced. On the anode side, H plus ions are getting produced. Okay. And when these two combine, we form HCOOH, which is your formic acid. That's the simple reaction we are actually taking apart. Thank you.